Alright, we're going to look at solving and graphing compound inequalities again today. We spent a lot of time last week looking at solving, but we didn't spend a lot of time looking at graphing. Actually, I don't think we did graphing at all last week with these compound inequalities. So let's just start with an example so we can kind of talk about what I mean by solving and graphing. And so if I wrote this down, negative 4 is less than 5 plus 3n is less than 20. And in the directions say solve and graph the solution. So don't just solve it, but graph the solution as well. The first thing I hope that you guys remember or notice is that there's more than one less than sign. There's more than one inequality. There's actually two of them. There's one here and one here. That's why they call it a compound inequality, because there's more than one. So anytime you have like two, you can never have three. You can have one or two. When you have two, they're called compound inequalities. The nice thing is you solve it the same way. So I think we're pretty good at solving. Our goal is to get n by itself. And I cover up the negative 4 and 20 because we don't care about things on the other side of the inequalities. We just want to get n by itself. So if I asked you who's bothering the n, you would say the 5 and the times 3. And which one's farther away? Positive 5. How do you get rid of a positive 5? Subtract 5. So the only difference is when you subtract 5 here, you have to subtract 5 on both sides. You have to subtract 5 over here and over here. The reason to do that is we have to keep both of these inequalities true. And so after that, I'll just draw my line like normal and I'll just do the math. Negative 4 minus 5 over here is just negative 9. When I subtract, I don't flip my inequality, so I just leave that as a less than. The 5's cancel out. I have 3n is less than 20 minus 5 is 15. So notice it, we got rid of the 5, but n's still not by itself yet. So if I look at it now and say, well, who's bothering the n? Now it's a times 3. How do you get rid of a times 3? Divide by 3. Now when you divide by 3, who else gets divided by 3? Both. Divide by 3, divide by 3. And again, we did this last week. Negative 9 divided by 3 is negative 3. Now this is the point where you got to really be careful and remember the rules on whether or not we flip these less than signs. If I divide by a positive, I don't flip. I only flip when I say flip, like reverse it, change the direction, when I divide both sides by a negative. And here I didn't, so I'm just going to leave the less than as a less than. 3's cancel out, leaves me n. 15 divided by 3 is 5. Now at the end here, we're always going to want these signs to be less than. You always want your numbers to go smallest to biggest. So negative 3 is the smallest, 5 is the biggest. This is something we didn't talk about last week, which is why some of your answers look different, and we'll see an example in the next one. The question is, what does this even tell us about our answers? Like when I say if n is less than 5, what are answers that are less than 5? 4, 3, 2, 1. That's pretty easy to figure out what the answers are. But what is this telling me? When you read this, you guys got a good idea of what this is actually telling you? What is that saying my numbers are? What are possible answers here? They're between negative 3 and 5. That's what it means. Can it be negative 3? No, because it doesn't have the equal sign on it. Can it be 5? No. It's all the numbers in between. And so when you graph it, and this is the part we didn't talk about, when you graph it, last time I said just put whatever number in the center. Well, here these are going to be like your endpoints. Like, so I'm going to say, well, negative 3 is my smallest number. 5 is my biggest number. And if I wanted, I could write negative 2, negative 1, 0, 1, 2, 3, 4, 5. Normally, because I'm lazy, I just write the negative 3 and the 5. The smaller number goes here, 5 goes here. And then we just have to make a decision about open and closed circles. So just as a reminder, if it's just a less than, it's open circle. The 5 is just a less than, so it's also an open circle. And then you guys had already said that this means my answers are between negative 3 and 5. And so what you would shade in is everything in between. So it's all the numbers between negative 3 and 5. And so that's the graphing part. No, nothing big. There is some strange things that happen, and I want to show you a strange one. So let's just look real quick at an example where something strange happens. On this one, I recommend that you guys try to go ahead of me and see if you run into that strange part. But the problem is -4 is less than or equal to 8 minus 2x is less than or equal to 10. There's actually two kind of parts where students might get tripped up here, but it looks just like the other one when you first start it. So it's hard to tell that you're going to get tripped up on it until you start working on it. If our goal is to get x by itself, and I don't care about the things past the inequalities, what's the thing farthest away from the x right here? Positive 8. So how do you get rid of a positive 8? Subtract it. So at this point, nothing strange has happened. Just doing the normal stuff. Notice where I subtract the 8 from: the far left side, the far right side, and underneath the 8 to get rid of it. -4 minus 8 is -12. Still, I keep my less than or equal. That subtract sign belongs to the 2, so I leave that as a -2x is less than or equal to 2. Alright, still trying to get x by itself. Now I get rid of a times -2. Here's where the first thing we got to be careful of. How do you get rid of a times -2? Now what are we dividing by? A negative. So when we divide by a negative, we have to make sure we switch the signs. So -12 divided by -2 is a positive 6. But then this less than or equal turns into a greater than or equal. That's an x. What about this less than or equal? It also switches because we divided by a negative, so that switches to a greater than or equal 1. Now I said that our answers are supposed to go from smallest to biggest. Right now they don't go smallest to biggest. They go from largest number to smallest. Now if you think about what this is saying, what is this saying your answers are between?
6 and 1.
It's saying they're between 6 and 1. There's another way though that the answer keys will write this, and this is important that you guys watch. They like it to be written from smallest to biggest. So if I rearrange and put the 1 first and the 6 last, and I rearrange them, x is still in between. If I switch the spots, what do I have to do with the signs? Switch the signs. This is why last week when you guys were doing your problems, some of you got this answer and the answer key said this, and you guys weren't. Yeah. Oh, is that supposed to be a -1? Sorry, -1. Thank you guys. But the whole point on this is when you get it from largest to biggest, what do? You switch it smallest to largest. When you switch spots, that's the second reason we flip signs. If I asked you to graph it, hopefully you'd feel pretty good graphing this. It's a terrible graph, but we'll make use. As long as you understand what this means my answers are between -1 and 6. Pay very close attention to your open and closed circles. These ones are closed because it has the equal sign underneath them. And then my answers are in between -1 and 6. The answers are in between there. So some people like to just draw arrows like this. Some people like to shade it all in. As long as you know that all the answers are between -1 and 6, then you should be fine. So those are the ones, we call these the ands. N is, or x is less than 6 and it's bigger than -1. The only other one that we have is called the ors, and so we'll make this our last one. Alright, so last one, -7 plus 6x is less than or equal to -61. And then this is what makes this different, or this, there's this word or in it. Or -7x minus 5 is less than 44. The only difference on this one is you just solve each of these separately. It's a compound inequality because there's still two less than or greater than signs. So anytime there's more than one, it's a compound. But this one, it's separated by or. It's not going to be both answers at the same time. It's going to be one answer or the other. And so you just solve it separately. Sometimes people like to just make a line right through the or and just solve them separately. Solving them separately is pretty quick because they're two-step problems. To get rid of a -7, you add 7. When I add 7 to a -61, that gives me a -54. Now this is where students will get confused. I'm dividing by 6, but I'm dividing by a -54 by 6. When I divide a -54 by 6, do I switch the signs? No, because I'm dividing by a positive. It's what you're dividing by that makes you change the sign. And so because I'm not switching the sign, it stays less than or equal. -54 divided by 6 is -9. That word or is still part of your answer. So x could be less than -9 or, and then you come to the other side and you solve it to figure out what else it could be. I would add 5 here, add 5 here. -7x is less than 44 plus 5 is 49. Now on this one, when I divide, what am I dividing by? A negative. And so when I divide by a negative, what do you have to make sure you do? You got to flip it. So this less than flips to a greater than. When I say flip it, it just switches the direction it's going. 49 divided by -7 is -7. So if we look at our answer, it says x can be smaller or equal to -9, or it could be greater than -7. And so if we thought about what the graph of this would look like, which number is smaller here? -9 is smaller than -7, right? So -9 would go here. You could put -8 there, and then -7. And then you're just going to graph these separately. Now last time the answers were in between those two. But if you look at this one, if we go graph it, the answers aren't in between anymore. X is less than or equal to -9 because it has the equal, it's closed circle. And which way is the arrow pointing here? Less than points left. So at -9, I'm going left. So I'm going this way from -9. And when I go to the greater than -7, that's an open circle. But this one's pointing to the right. And so instead of going in between the two answers, it goes away from each other. Oftentimes I think of the ors, the or statements, as horns. Because the or statements are the ones that go away from each other. And so they kind of look like horns coming off. The other ones are the ones that go in between each other. So that's how you would graph those. And that's it.